Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is subtract or divide. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given a positive integer n, and in one operation we can do the following of this. If the value of n given to us is greater than 2, then we can change n as n minus 2. And in case our n is greater than 1 and it is an even number, then we can change our n to be equal to n divided by 2. Now we need to find all the different positive integers that we can form if we are allowed to perform as many operations that we want, either of these, starting with n. Now we are allowed to perform any different operation at any different type. Now let's see the input format. We have t test cases, and for each test case we'll have a single line, and in that single line we'll have the input integer n, and for the output in a single line we'll have to output a number that is the distinct positive integers that we can form by performing these operations as many times as we want. As for the constraints, number of test cases will go from 1 to 100 and value of n will go from 1 to 10 raised to 9. Let's see some sample inputs. So we'll ignore the small numbers and let's try the bigger ones. Let's say we go with 6 and 8. So if I'm at 6, this is a positive number that is even and greater than 2. So obviously I can do the first operation, that is I can decrease it. I can decrease it to 4. I can do the same with 4, and when I'm at 2, since this is not greater than 2, I can perform the second operation, that is dividing it by 2, and I get 1. Now with this I have the even numbers. What about odd numbers? Let's say when I'm at 6, I do the second operation. Now I have 3. Now for 3, I cannot perform the second operation. Second operation can only be performed on numbers that are greater than 1 and even. So what I will do is, I will perform the first operation. This becomes 2, and from 2 I can only reach 1. So the number of distinct integers that I have is 1, 2, 3, 4 and 6. So a total of 1, 2, 3, 4, 5. A total of 5 distinct integers I can get via 6. Let's see what we can get from 8. So when I'm at 8, again, we can get the even numbers. We can get 6, we can get 4, we can get 2, and where we can get 1. Now let's say we perform the second operation. If we perform the second operation, we get 4. Well, we already have the 4s, not needed. Let's go with the 6. If at 6 we were to perform the second operation, this will give us 3. So again, from 3 we can go to 2, and from 2 we can go to 1. The number of distinct integers 1, 2, 3, 4, 5 and 6. So for 8 we have a total of 6 distinct integers. Let's see how we can approach the solution. So when we are given an n, the value can either be odd or value can either be even. Let's first check what to do if we have an odd number. So if we have an odd number, we cannot perform the first type of operation. Since, we cannot perform the second type of operation because the second type of operation says that our n has to be greater than 1, that is fine, but additionally n has to be equal to even. So this means that if n is odd, this operation cannot be performed. And if you subtract minus 2 from any odd number, it will always give you just odds. So in case, let's say we have 5, we can decrease it to 3 and then we can decrease it to 1. There is no way that we will reach any even number. So if our n is odd, we have a very direct answer. We can reach all the odd numbers in the range 1 to n. That would mean nothing but we can reach all the half numbers. Half would be even, half would be odd. So this is here. Now what about even numbers? If we have even number, we can try to do what we have done in the sample examples. So if we have an even number, let's say we have 100. So first we can do the minus 2, the first type of operation. So with this, we'll get all the numbers till 2, right? We have all the even numbers with us. Now how about odd numbers? So let's say you can try to apply the second operation. So we can only apply the second operation on even numbers. So let's say we apply it on 100. If you apply it on 100, we'll get 50. Now again we have 50. If you do the first type of operation, we're only going to get even numbers. So this is not helpful to us at all because we have already reached 50 in these even numbers. What about 98? Now if I apply the second type of operation, I get 49. And from 49, what we have done for n as odd numbers, we can do the same. We can keep applying the first operations and then reach 1. So if you see, first of all, if n is even, we will obviously get all the even numbers here. This represents all the even. Now we'll check whether the first number, the n that we have, if we would apply the second operation, that is, if n divided by 2 is odd, if n divided by 2 is odd, then it would mean that we can also get all the half of all the odd numbers that are in the range 1 to n by 2. That would mean that it would be n by 4. What if, like this case of 100, n by 2 is not odd? We'll check the second number, that is n minus 2. And one of them will always be odd. If this is odd, then our answer would be n minus 2 divided by 4. So for even, our answer will be nothing but n divided by 2 plus one of these, whichever one gives us odd. So with this, what we'll do is, for n is equal to even, first we will capture all the even numbers via the first operation, and then we'll apply the second operation on either n or n minus 2, and from there we'll capture as many odd numbers as we can get. And this will give us the maximum number of distinct numbers that we can get. And this is our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n. Now we know that whether n is even or odd, we can get either half the odd numbers or half the even numbers. So first of all, our answer will always have n divided by 2. Now to make sure that we get an even number, we are doing n plus 1 divided by 2. Now once we have this, we know that if it is even, we are getting half the even numbers. And if it is odd, we are capturing all the odd numbers in the range of 1 to n. Now, in the special case when n is even, what we can also get is we can also get odd numbers. So for that, either n has to be the first n has to be giving us odd if we apply the second type of operation. That is, n divided by 2 has to be odd. If that is not the case, right, then we need to check whether n minus 2's half, that is the second type of operation on n minus 2, gives us a odd. So if n by 2 is a odd, we will take that number. If that is not the case and n minus 2 divided by 2 is a odd, then what we will do is, with this odd number that we have get, this x that we have, we'll perform the first type of operation and get as many odd numbers as we can get. That will be nothing but this number itself divided by 2. That is, we can get half the numbers will be odd, so we can get them and we will add it to our result. And as you can see, I've got an AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n, initialize our answer as n by 2. That is, if it's odd, we are going to capture all the odd numbers between 1 to n, and if it's even, we are going to capture all the even numbers between 1 to n. In both the scenarios, we are going to capture n by 2 numbers. Now, especially for n as even case, we can also capture some odd numbers. For that, we'll check if we apply the second type of operation on n or n minus 2, which one gives us the odd number. Whichever one gives us the odd number, from there 1 till x we can get all the odd numbers in the range. And how many odd numbers would there be? There would be x by 2 odd numbers. So we add that to our result as well. At the end we print this result. And as you can see, I've got an EC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.